learnt that a triangle can be constructed when its three sides are given. Or two sides and an included angle between them is given. Or two angles and an included side is given. But these parameters may not be known every time you construct a triangle. Other than these parameters, can you apply any other properties of a triangle to construct a triangle? Yes, you can. You can use inequality relations and perimeter of the triangle while constructing a triangle. It is possible to draw a triangle if the base, sum of the other two sides, and one of the base angles are given. Or the base, difference of the other two sides, and one of the base angles are given. Or the perimeter and base angles are given. Let's see how to construct triangles using these criteria here. How do we make sure that the construction methods used to draw the triangle when its base angle and some of its sides are given is valid? Observe that in both methods, base QR and an angle Q are constructed as given. Now, look at triangle PRS constructed using method 1. The triangle has angle PRS equal to angle PSR by construction. Therefore, line segments PS and PR are equal because sides opposite to equal angles are equal. Hence, triangle PSR is an isosceles triangle. In addition, triangle PRS constructed using method 2 is also an isosceles triangle because if in a triangle any perpendicular from the vertex bisects the opposite side, then the triangle is isosceles. Hence, the sum of sides PQ and PR is equal to SQ, and thus the construction is justified. Now, using which of the two options can you construct a triangle XYZ? Option A enables you to construct triangle XYZ as the sum of the lengths of other two sides XY and XZ of the triangle is greater than the length of the base YZ. However, in option B, the sum of the lengths of the sides XY and XZ is less than that of base YZ, and hence constructing triangle XYZ is not possible. How do we make sure that the construction methods used to draw the triangle when its base angle and difference of its sides are given is valid? Observe in both cases, that is, case 1 and case 2, that triangle PSR has line AB bisecting line SR. Hence, side PS is equal to side PR, because if the line from the vertex bisects the opposite side, then the triangle is isosceles. In triangle PQR of case 1, side PQ is equal to the sum of the measures of line segments PS and SQ. While in triangle PQR of case 2, side PQ is equal to the difference of the measures of line segments PS and SQ. Using equation 1, we can modify equations 2 and 3 as equations 4 and 5 as shown. In both cases, the length of SQ is 3 centimeters. Therefore, we substitute the length of segment SQ in equations 4 and 5. Hence, in case 1, we get the difference between the lengths of line segments PQ and PR equal to 3. And even in case 2, we get the difference of the lengths of segments PR and PQ equal to 3. Therefore, the construction is justified. Now, using which of the two options can you construct a triangle XYZ? Option B enables you to construct triangle XYZ because the difference of the lengths of the other two sides, XY and XZ of the triangle, is less than the length of base YZ. However, in option A, the difference of the lengths of sides XY and XZ is greater than the length of base YZ. Thus, constructing triangle XYZ using the parameters specified in option A is not possible. How do we make sure that the construction method used to draw the triangle when the perimeter and the base angles are given is valid? Observe that in triangle PAQ, the line passing through the vertex Q bisects the opposite side PA. So, triangle PAQ is isosceles. Hence, side QA is equal to side QP. Similarly, in triangle PBR, line through the vertex R bisects the opposite side PB. So, triangle PBR is isosceles. Then, side RB is equal to the side RP. From equations 1 and 2, we can say that the sum of the sides, side QP, side RP, and side QR is equal to the given perimeter, that is 11 centimeters. Using exterior angle property of a triangle, in triangle PQR, we get the measures of the base angles, that is, angles Q and R equal to 60 and 45 degrees respectively. Therefore, the construction is justified. Triangles can be used to estimate distances. First known use of triangles was made by Greek mathematician Thales in computing the height of pyramids. Nowadays, scientists make use of triangles to find the distance of unknown stars from the Earth. They make a triangle by taking one of the known celestial objects, maybe the sun or the moon, or some other known stars or planets. Another well-known use of triangles is made by surveyors to determine the distance between 3 points. To be able to use triangles to find distances, etc., it is essential to know